Welcome, everybody, to another episode of Discussing New Approaches. This is the show where we delve into everything cutting edge and new in AI, data and technology. My name is Eric Walker-Rawson. I am your host. But today I'm joined by Khalid, who is the Chief Scientific Officer and also Head of Data at Sensat. And today we're going to be talking about a lot of different quite data-heavy topics, geospatial data, digital twinning, as well as AI. It's also going to come up. So I think we'll jump straight into it straight away. So do you want to give me a bit of an overview first? Do you want to tell me what is geospatial data? Let's start there.
Well, geospatial data is any data that has some sort of a location available for Earth. So any data that you can locate it onto a map is geospatial data. It comes in many shapes and forms. It could be a satellite image. It could be just digitized maps. It could be a location of something. We're very familiar with using geospatial data. It's Google Maps is your geospatial data. Your GPS on your phones is geospatial data. Quite a lot of the data that we actually use nowadays is geospatial. But in general, it's nothing more than any data that has some sort of a location associated to it.
So is this going all the way back to obviously like things like cartography, where we had maps? Oh, yeah. And so does it have its roots in that? And
absolutely.
I suppose, when did it become digitalized?
Pretty much around the 80s time when it started to pick up. The industry or the technology in those days was called geographical information systems, mainly digitizing the maps part. And then started to associate computing to it. So now the maps are digital. What can we do with them? And then one of the applications of that compute you would use pretty much every day is trying to find your route from one location to another. The old days of A to Z or big maps books that you open up and then start to draw things, all gone. Because computers could do that for you but the idea was to have the maps in digital form first, in various shape and forms. But also imagery. Imagery gave us satellite imagery mainly, started off with, gave us a lot of information about our Earth, quite sort of high-level views of disasters or environmental scenarios, even urban expansions. So we started to realize exactly how humans really live based on the imagery and the computers associated to it, the algorithms behind them. But that's the start of the geospatial pretty much in the early, in the 70s, 80s. That's where it pretty much boomed up. And then since then, it's just been picking up and evolving over a period of time. As I said, I'm old enough to have seen that start of the geospatial world, or the technology behind it. And the technology is young enough that I have seen the start, and now we're pretty much in the peak of it.
Amazing. And so what's actually involved in collecting this type of data? So you mentioned satellites. I'm guessing huge amounts of data being collected from satellites. You get the cars that are driving around, the Google cars, if you've ever seen those, taking pictures, everything
Pretty
else.
much everything. I normally describe the geospatial data capture as a stack, basically. So you can start at the ground and you can go into the space. Satellites are sitting in the space, but space also has multiple layers of satellites sitting in there, like closer to the Earth, which is normally called the near-Earth object, NEO. And then furthest away. The further away you go, the satellites tend to move with the Earth rotation. So they're always looking at the same location all the time. Those are the satellites that are normally used for like weather monitoring. So they want to monitor a particular region all the time and continuously see what the weather pattern shifting. The closer to the Earth orbits that you come to, then the satellites are just wrapping Earth in data, basically. It's like a ribbon of data capture happening all the time, pretty much every minute, every hour, every day. And there's a huge amount of satellites, and there are thousands of them. Not all image-based, but communication, related to that. But then you come within the atmosphere, and then you have planes. They also capture data. And then you come one step below towards the ground. Then you have UAVs and drones, as we know as. They're flying around. Helicopters as well. I'll call them the plane surveyor, but they can come closer to the ground. Drones, obviously, past 10, 15 years have become a very, very big tool to capture data sets, especially in geospatial data in terms of mapping. Then you pretty much come down to the ground, and we then fall into the realms of surveyors. They used to capture, very high detailed geospatial data. But nowadays, you have laser scanners that you can put them on a tripod, just like a camera, and they just go tick, 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 and then they capture the environment in extremely large detail. And I'm talking centimeters to millimeter detail. You also can then plant those cameras and laser scanners on top of a car, and you start driving around instead of a static tripod. And then you can start to pretty much capture your urban or your non-urban environments in huge amount of detail. We have a lot of geospatial data captured in the past decades, and I can't even give you a number. It will be in exabytes, thousands of petabytes, probably even more so. So, a lot of geospatial data. One of the things with satellites is that the higher you go, the larger areas you cover and less detail you cover. The closer to the ground you come, you start to capture a lot more intricate details. So none of the data capture methods in that stack are competing against each other. It's just what type of data you need to use for your project or for your use case or for your problem that you're trying to solve decides what type of data capture you need to deploy.
And what sort of, so with the satellites that are in ultra detail and then the satellites that are further up and capturing a more broader amount of data, what are they for? What are you using that type of data for? I mean, obviously things like the Met Office, I'd imagine, for weather prediction. But what are some of the other, I suppose, practical applications?
You do have, the further away you get, the aim is to cover a much larger area of the ground on Earth. So you start to get a bit more applications like, weather is the most common one, but you can also start to look at vegetation pattern changes, but on a continental level, because that actually, can be used for predictions of seasons and weathers and how the weathers are affecting things on the ground in terms of social aspects as well. But those are covering mainly for weather monitoring. Then you come closer, and then the applications vary from disaster management, disaster mitigation, assessment of disasters like earthquakes or flooding. But the beautiful things about satellites is that they can see more than what we can. At least they capture data that our visual systems, human visual systems, are not designed to. We normally see things in combination of red, green, and blue. But satellites, what we call multispectral data sets or multispectral sensors, on satellites can see things in near infrared, thermal infrared, so they can actually see heat. So depending on what they are actually capturing, then you start to use your applications based on that. So thermal data sets can also be used for monitoring urban heat island effects, that, how they are affecting certain places. We can also monitor pollution levels based on satellites. So there's a lot of applications, but again, normally cover larger areas. So you can go from pretty much half the globe from all the way to the top to low Earth orbits, which still can cover pretty much national level or even regional and city level data sets.
Wow. And you mentioned it was a massive data set. So I sort of want to try and contextualize that a little bit. So how big do you say, was it petabytes or even more than that, the levels of data?
Yeah. I mean, I'm pretty sure somebody's done some calculations around how much geospatial data just from the satellites that we're sitting on. A gigabyte, there's about 1,024 gigabytes in a terabyte. and then 1024 terabytes is a petabyte, and you can carry on going. And I'm pretty sure there is sort of a huge amount of exabytes coming after that. So it's more than what normally we actually consume.
Is it more information than the internet potentially? Or what's a comparable data source, I suppose?
Gosh, really that's a good question. That's very trivial, but I mean, if you say that data set is sitting on the internet, so it can't be. It's a subset of the internet. We're sitting on a lot of data set at the moment, but not extract. I don't think we extract enough value from it.
What are those some of the challenges that we're not extracting enough data or value from that data in these sort of huge data sets?
I think, that's exactly where our journey as Sensat started off, because 2017, we were basically a drone company, but in geospatial space, because we could fly UAVs, drones, and turn those images into 3D models, quite detailed, 2 centimeter, 3 centimeter resolution. And the resolution as in you could see pretty much this table and things sitting on top of it if it was outside in 3D.
Wow. So
think Google Earth, but when you get to the ground level, you could see a lot more detail. Google Earth does not allow you to. So we could do that, and we were pretty happy. We thought, okay, we can start selling that data, which we did. We decided we had to choose an industry, so we did, and we chose infrastructure, construction mainly, because they needed that data quite rapidly. And the good thing about UAVs and drones is that you can deploy them whenever you want to, basically, based on the regulations. But as long as you have permissions to fly, which we did in those days, we could deploy that data, and we can get that data to people. Again, a lot of generation of data, and we normally used to deliver data on hard drives. And then the client will sit there and goes, great, this is exciting. And then they had nothing to visualize that data with. So we pivoted a little bit at Sensat, and we started building software, a web-based software that was accessible to pretty much everyone, even non-expert people could actually utilize and visualize, and then eventually get value from that data set. The value comes in, again, very different ways, depends on what really is the problem that you're trying to solve. Data never comes in first. The problem comes in first, as in you define what the problem is you're trying to solve, then identify what type of data will be useful to solve that problem. Then you can think about analytics around it as well. And then you get some sort of answer, and you basically say, okay, yeah, I think I've got my result, and that data was quite useful for it. The type of problems we were solving, obviously, in the infrastructure industry, also known as sort of ICO, as in architecture, engineering, construction, and operations. There's various life cycles. So you have planning stage, where asset doesn't exist in the planning. Then you have the construction or the build phase, where actually asset being built. And then you sort of go into the sort of operation phase as well, where the asset does exist, has existed for a while, but the customer doesn't know how it's performing, or if it requires any maintenance or not. So there are different phases, and then the data adds value in different ways to each phase. In planning, you're looking at the environment where you want to build in various level or granularity of details, from satellite imagery to digital maps, to flood models, to seeing what sort of a current social or urban infrastructures are out there. So when they build some sort of a large infrastructure like railway or new roads coming in, or even energy expansion, substations being made larger, or solar panels being put in, any type of planning, then you can start to look into your environment and say, okay, I'm trying to build here. Does it fit all the requirements, either the construction requirements or even regulatory requirements as well, from environment to social? Mm. And in construction, you're deep into the build phase, so you want to monitor it a lot more quicker. So you keep flying drones. We have a customer that is deep in the construction phase, and they have their own UAV team, drone team. They capture data every day of this site to be able to monitor it and see how they can manage the logistics. And in the asset side of things, operation side of things, it's a bit more like, let's say, imagine M25, a very large asset, and we capture it once a year, once in 2 years, and then they can then start to use that 3D model, which pretty much is their visual. The idea always is that you're trying to bring that physical environment into a digital realm to an acceptable granularity of reality, closer to it, and then see if you could do things, ask questions, solve problems in that digital realm.
Is this where the digital twinning?
Absolutely. That's where the digital twinning comes in. Okay, the concept is quite old. Actually, it might come from the old days of NASA. So imagine sending a lunar mission and not being able to test it because you've never been out there, right? So you end up creating the whole environment and simulations of it in a digital world. And you put very clever people behind it to replicate what they believe is the world outside in the space or the lunar surfaces, and then you simulate. And that becomes a digital twin of another asset. So the original concept is there. In those days, the digital twins were very numerical. You know, they will run through some equations to form scenarios or to play around with scenarios. But nowadays, the concept has become a little bit more like people think you can just create a digital replica of anything. I've even seen articles of digital replica of people. So you can have human digital twins, but that's a different conversation. In our field, infrastructure digital twin has always been a dream world for asset owners. It's a bit like you have a very complex infrastructure, but what if you can actually replicate it in visual sense, also in operational sense in the digital world? Then it becomes like a SimCity.
I was going to say, is gaming linked to, in a way, or
I would love it to be linked more to the gaming. There is an overlap in the technology side of things, but the idea really is that a digital twin you should be able to use your digital twin to simulate some scenarios or manage your operations. As I say it, break it in the digital realm, learn from it, and then apply in the physical world.
So are you taking a lot of those natural data, so like hurricane information, flooding information, all of that data, and applying it to this digital twin, and like, what happens if you get an earthquake? What happens if there's a flood? What happens if, all of these sort of different types of scenarios, and then seeing how you can stress test this digital twin so you can then prepare for the future?
Pretty much. We're not there yet. So, but that's the ideal world where you should be able to simulate and get better predictions from a digital twin, that what if sort of questions can get answered. Right now, again, as I said, the digital twin went through a big hype that we can actually create digital twins of pretty much everything. We have the technology to be able to do that. But it didn't really play out that well. And one of the reasons was that we really wanted a silver bullet to be able to do everything for us. I remember UK, one of the nations that wanted to create a national digital twin, still in conversation, and there's a lot of good work going around in that place. But that's ambitious. But I don't even know how to break it down to what sort of granularity you can actually do.
So for anyone not familiar, what would a national digital twin, what would that entail? Because if people haven't heard of that.
Imagine pretty much from sort of high level monitoring of your country's environment to operations on local governments, to any type of, traffic management even, but perhaps. But any type of stuff that government is designed to do, their national security, their energy infrastructure, it's complex.
Are there also privacy securities and security concerns?
That's why it hasn't come to to fruition. But the idea is that the concept's not a bad concept. It's just it becomes complex when you start thinking about it as a national level. So what you've got to do is that you've got to start focusing on certain things first, as in, can we create a digital twin for the energy infrastructure to start off with? And can we create a digital twin for a water sector for a start off with? And you break it down. And then it becomes a concept of, okay, so each digital twin can actually replicate the physical environment and possibly the operations within it. So it becomes a system on its own. Can you then connect the system so that the national digital become a system of systems? Again, quite complex. But the idea really is, in my opinion, that the digital twin, although went through a hype, and then now whenever I speak to people in the industry about digital twin, they always put a double quote around a digital twin. I still think there's a huge amount of value in there. So at Sensat, what we've done is that we've broken it down and said, okay, why don't we give you a visual twin first? So you can actually see, just replicate your asset into the visual world and then play around with it in that visual space. Create your own data sets as a user. Also takes away the expert stack, which normally people who normally will analyze the data before it can get to the decision makers. We just say, no, play around with it. Play around with your asset and see what it looks like, what it feels like. Start to add more data to it to get more understanding of your assets working in that visual space, not in the analysis space. Analysis is important. But so we create that first, and then people started saying, okay, we have a problem they can solve here. We can have a problem I can solve here. I want, for example, to control pollution events from water industry. So let's put some flood data in and see what it looks like and which areas will get affected if there is a leakage from our water treatment plants, for example. Or you can have I have a telecom infrastructure. I have an exchange, for example. If the flood happens, which areas are going to flood first? Just see it. There's a lot of analysis behind it, but once you see it, then what you're doing is that you're actually bringing very complex data set and bringing it closer to the decision maker. Otherwise, they had to go through quite a lot of different analytics. But by just seeing it, sometimes you can go, there is a generator setting at the low level. It's about to, if that stream floods, the first thing that's going to get flooded is our generator, for example. It's visually you can see it. So we're trying to sort of get that visual twin in there first. And but there is a lot of work that we need to do. I mean, imagine the huge quantity of the data that's actually sitting out there. Even with the technologies that we have nowadays, we can't consume all of that data set. There is some level of, the modern large sort of language models have shown that they can consume huge amount of data, like the whole of internet, for example, text-based internet, and then start to give you value as you can question it. Okay, so imagine that power given to geospatial data. That's quite something. And there's some experiments and some proof of value has already been coming in there that how useful is the AI in that digital twin space. Does it actually target the ingestion or understanding of the geospatial data, or can it actually do the analysis part of it as well? But there's a lot of work that still needs to be done to make the digital twin technology a lot more mature and valuable. In my mind, the digital twin is not the software part. It's the whole ecosystem around what you want to do with your asset, for example.
So is this similar to things like low coding and it's sort of what people might call now vibe coding? Not directly that, but the idea is breaking down the barriers, like you said, to decision makers to be able to play around with data where there would previously have been a technology barrier. In the same way that if you previously wanted to have a conversation with your data, you'd probably need to learn coding in some shape or form. Whereas now with the advent of LLMs and other AI tools, it's opening that up where everyone can start having conversations with their data set.
Absolutely. And that conversation piece is quite important Prediction can eventually come in as well within it. But the conversation piece, just trying to understand what my asset looks like, how it performs. Just please describe things for me, or even search for certain things within images without actually training large sort of models to be able to recognize, for example, just the building footprints, because that's how the geospatial AIs have evolved. Or let's do object recognition. Let's identify all the buildings and all the trees, all our roads. Build like residential areas, differentiate from commercial. We've handpicked the objects that AI could recognize. But now we've seen the power. And again, the technology's been there, but it's just people have more trust in it because of the likes of Gemini and ChatGPT and Claude, that you can speak to your data. And then people go, wow, this is amazing. I'm getting answers that experts would normally give me. But that's exactly what's going to happen with the geospatial world. And then as we have large language models, we also have started to see a lot of large geospatial models coming in, and they're very much image based at the moment. But there's a lot of geospatial, non-image geospatial data like maps going in there as well. OpenStreetMap, which is a sort of a Google Map equivalent, all of that data going into those models now. So you should be able to not just find out where a particular business is or a particular location, where's my nearest swimming pool or where's my nearest lake. You can do that, but you can also say, okay, well, if my water treatment plant is sitting here, and if it leaks, is that going to go into the lake or not? That's a very analytical sort of problem that has a very analytical solution. But it's possible now that you can actually just look at your data and go, oh, my water treatment plant is sitting right next to that stream. If this particular tank leaks, will it pollute that particular stream? You just ask it.
Is there a practical application for the public as well? So where my mind is going to with that type of application where you're, again, it's slightly predictive, it's taking lots of different types of data sets. So let's say you're moving house and you're going to a new area and you are trying to understand the area. Usually you'd go around, you'd speak to your neighbours. I suppose that's sort of boots on the ground data gathering. But if you had this sort of program in my mind, and you can correct me if I'm wrong, it would be like, well, actually, you're in quite a high risk flood area. So if there was a flood, your house, bottom layer of your house would be flooded, or you are in a subsidence zone. So you need to think about that. You need to question the surveyor to make sure they're doing that. And so it'd be able to make, again, if you're thinking decision maker, so the buyer of the house is the decision maker, like a CEO in a company, it's giving you data to make an informed decision on whether you buy a house or not in those areas.
Yeah, absolutely. And not just from that, you can actually start to socially evaluate that particular area, because you normally would like to visit that area at certain times to see what sort of disturbance these regions really get before I buy my house. You should be able to now. UK government is very good at generating social environmental data sets. We have certain departments that will generate that data set for you. It's just very difficult to consume all of that data together and for public to be able to make decisions around it. But imagine all of that data going in some sort of a geospatial model, and then public can actually just speak to it. What happens at 9 o'clock? Where's the most crime happening in that particular region? Is there any social deprivation? What's the pollution like around this area in certain times of the year? That could be very useful in the public domain as well. So
I was going to say, is that where you see it being a massive benefit both to the public and this would also be accessible to companies as well. If you're going to do a new development somewhere, thinking of construction, you want all of that available data. So again, it's just a questionable data source with the government that has a large amounts of data that is available to question.
Yeah, I just jump back a little bit, like all the way back when you asked me the value of geospatial, and then I'll answer this question after that. The geospatial data it's everywhere. Okay, every organization in the world, from local authorities, government level, commercial, defense, can't live without geospatial data. what it allows you to do is allows you to first see things where they are, but then allows you to then create relationships, build relationships between those objects. You know, how far is X from where I am? That's quite a common little query. Is it busy at that particular time? Google can do that. It can tell you that nowadays. Is my train on time? Again, you know, so there's a lot of geospatial data. Now, bringing it back, now, if these models and if the AI actually starts to analyze that data and give you a little bit more of the conversational piece with your geospatial data, yes, it's everything. Every organization, from commercial to government to public sector defense, will hugely benefit from it. There's a massive, massive industry that's about to open up. It's always been there. So the GIS world I was speaking about, that's quite a lot of the applications that you see. Everything has a map associated to it. Every piece of, like, you know, you want to talk about insurance, there's maps showing risk maps of where the insurance. It's already been doing that, but it's about to evolve into a new realm where it will be conversational. You know, the biggest risk I see with it is the whole privacy part of it as well, but also the trust part. Do I trust the answers that large language models give me, that I have conversations with every day? I do question them, but I have to be experienced enough to know if certain questions are going in the right way or not. And so there will be a little shift in the knowledge domain of people using these models as well. But yeah, it will open up a new era of different problems that we will, and then we'll solve them as well. But I can assure you that the digital twins are about to give values to particularly commercial asset owners or any type of digital twinning that you actually want to do. It will have a lot more predictability power. Trust will come with it. It will evolve. They will get better at it. As you've seen for the past, 5 years or so, these language models have evolved. You know, early days, it's like, no, that's not true. And then every time I say it's not true, and he goes, sorry, I'll try again. Oh, no, sorry, again. But they apologize less now because they're giving you better answers or answers that you want. So geospatial models will evolve eventually as well. And I foresee it could all go wrong. That whole geospatial stack, data stack that's generating data sets in petabytes, will suddenly nobody will talk about it. Nobody will say, oh my God, how much data do we have? What are we going to do with it? No, the value will sit with those digital twins that are conversational and said, I know exactly what my asset looks like. I know exactly how it behaves. And I can automate pretty much quite a lot of the stuff within it. I can automate sort of, temperature control based on a lot of environmental factors outside. I can
automate. Is that then applying agentic AI to actually go and make decisions for you?
I was hoping I won't say the word agentic. But,
I've got you.
Agents have been around for a very long period of time in terms of modeling. And nowadays they've started to do a little bit of AI. Well, I have to throw this plug now that you've seen Matrix.
I have, yeah.
There was a character in there called Smith. He was called Agent Smith. He wasn't an FBI or a government agent. He was actually a computer agent that eventually learns how to replicate himself. He had a task to do. That's what agents are like. Agents are task-driven at the moment. And so agent-based modeling has been around. Flooding, prediction of flooding has used agent-based modeling since the 80s and the 90s and the early 2000s. Nowadays, those agents, single agent, can actually do task-based, but use AI to do those tasks. Agentic AI is a group of agents that are orchestrated in a way that they work together. So, and then as a computer scientist, as a data scientist, as a tech geek, I am absolutely excited, like super excited about the orchestration piece. I love it. It's very similar to drone swarms.
I was going to say, yeah, drone swarms. I really like the Agent Smith analogy, partly because I like the Matrix, but I think because again, it's rule based, but it's a collection of rules and a collection of purposes that you're giving them that they're able to complete those tasks all working together. You know, in the case of the Matrix, it's capture the real people that are breaking through.
So yeah, rule based will evolve into objective based. As in, you are an AI agent, you have this objective to do, go and achieve it, please, in the most optimal way. And then you have multiple agents with their different objectives or similar objectives, and then you're trying to find the most optimal solution to a complex project. So imagine, the whole thing we used to say that take a big problem, complex problem, break it down into smaller problems and tackle each problem. I imagine each problem is being tackled, each sub-problem is being tackled by an agent. But it still belongs to a larger problem. How are you going to bring it all together? That's your agentic AI that's going to bring it all together. So single agents, yes, very useful. Agentic AI, it's a young field, and there's going to be a lot of evolution. But yes, it is exciting.
Could be whole departments of agentic AIs doing certain things or tasked with certain problems. I suppose tying it to the future then. So I'm going to say, can you try and conceptualize the future? It's a very, very hard question, but can you conceptualize the future of digital twin, geospatial data, throwing in things like AI, agentic AI? I'm even going to throw you a couple of other curveballs like quantum computing and even AR and VR at the same time when thinking about the gaming and the visual elements. So if you're taking all of these bits of these technologies, what could this realm turn into?
There was a lot of AR, VR. I think they're all part of the same technology stack. It's our visual space. There is a lot of, there's an organization called Niantic. You might not know the name, but if you do, you would know. They're the one who built Pokemon Go. That's your AR world, right? But the creators of Niantic, the founders of Niantic, they're not this familiar with the geospatial world because they were the original creator of Google Earth before Google acquired them. And so they know the geospatial world. They've been playing the long game. I love the way they actually went down the whole AR route, but just to make sure they can understand how data can be collected and pushed back into that physical world. The linkage between the digital and the physical world.
And also the user, I imagine as well, in the same way with Google, where it's the users feeding data back into by use. If you're going from A to B, it's collecting data on your journey from A to B, traffic data, other things,
Yeah, they Google normally won't collect user data because they have their own source of data collection techniques. So, but there's for example, traffic data, there's an app called Waze that's again owned by Google, so they collect the traffic monitoring data from that to relatively real time. But the idea that the AR VR, it's all part of that same stack. The future of geospatial and digital twins is that the world, we've been struggling. When the GIS world started, when the geospatial technology and compute, they started off, we said we need more data. We need to turn our analog data sets into digital data. And then we start collecting data, and then we have too much data. Then we go, okay, we need algorithms to be able to process that. Oh, now we've got too many complex algorithms. We need experts to be able to decide what sort of problems we're trying to solve. It just went in, and we started to go deeper and deeper and deeper down this rabbit hole. That rabbit hole, we're about to come out. Your digital twins, probably the term will disappear, because if you think about it, Google Earth is a sort of digital twin of your globe. It's not real time, but it's quite a nice visual representation. So it's a digital twin, right? And we will have that. We will stop talking or calling it digital twins. It will just be a nice physical digital replica of your physical asset, whatever that asset might be, a house, as a public domain. You can see all of the automations within the house happening in that space, and you control it in the digital space, and your house responds accordingly, not too far away from smart homes. You can take an energy grid behaving in that same way, but there's more predictability associated to it. There's more operations associated to it. There's traffic management. You know exactly how a particular phenomenon like a flooding or extra amount of rain will potentially cause traffic chaos in a city, and so you can mitigate it beforehand. All of that will happen in that digital space, or we at least will be able to simulate that. We won't particularly call them digital twins. The aim has been to do that, but now with the improvement of these large models, be it geospatial language models, it will just open up that. It literally will just go, okay, now we know how to build these. There's still a lot of exploration needs to be done, but that's about to come in the next 5 years or so. No, I'm not talking 10 years or 20 years. You will see that. You will use these technologies for your own use. What was the other?
Quantum as well.
Oh, gosh, yeah.
That's
quantum.
another rabbit hole.
Everything that we do in days and years worth of compute, it will just squash down to a very small amount of time. It's not just about of time in compute, the complexity. At the moment, a true spatial, environmental, geographical phenomena, whatever you take, prediction of earthquakes, for example, is a multivariate lot of variables within that. And it becomes extremely complex. And human experts in the domain will start to go, let's break it down. Quantum not just will allow us to do things faster, but it allows us to just simplify that complexity, or to just take care of that complexity, please. So without going into the detail of it, yes, that is another field that's going to just open things up a little bit. The humans will play a huge role, and I think the most important skill from humans that will be required is the creativity part of it.
What problems are we going to solve?
Yeah, exactly. And I'm not just talking about the creativity in terms of, I can do art or, it's actually generation of new knowledge, which only sits with human at the moment. AIs don't do that.
Which is quite a nice, I'm an English literature grad, and whenever you're looking at creating new art, you want to look at the history of what has been, which is a weird correlation to make, but it's what we're really moving towards is a similar thing where it's like, in order to create new, you need to know what's come before. And the interesting advent of all of this is that we'll now have everything that's happened before potentially at our fingertips. And then potentially, if you include quantum, infinite digital world to be able to do simulations. That's maybe quite far in the future, but it will all help to actually put this sort of digital twin element on steroids. Yeah,
absolutely.
Some interesting things with it and solve interesting problems.
Technology will be there for us to use, and how we use it appropriately, it'll still sit within our domain. What sort of problems we need to solve is still within our domain. It won't solve everything. Global hunger.
Yeah, that's true. Yeah, still need that human ingenuity.
Of course, always. And as I said, the power of creation at the moment still sits with us.
Perfect. And I think that's a great place to stop, sort of in that human ingenuity bit. But that's all the time we have now. So I want to say a big thank you to Khalid for coming out and having a chat with me. Where can people follow you and see how you're developing these types of technologies?
Nowadays, the platform for talk about all of this is pretty much LinkedIn for us. We have a lot of going on. We're working on the geospatial AI side of things as well. So either follow Sensat or follow myself, and you'll see my team's doing a lot of bits and bobs around what we've spoken about in the AI space and the digital twin space, but in a wider context as well.
Perfect. I'll put all those links below. But thank you for tuning in, and subscribe, follow, whatever you're viewing this on. Go do that now. And put any questions you have in the comments below, because we'll follow up with Khalid for any question and answer, maybe even do a follow-up in the future to keep the conversation going within our community and everywhere else. But bye for now, and see you in the next one.
Thanks for having me.